Hello everyone, and welcome to the on-site question 3 solution for the rideshare startup company. This problem, you've actually already seen it before in the tree section of this course. It was given a binary tree, check whether it's a binary search tree or not. So, you're given it that it's binary tree, but you need to know if it's a binary search tree. Now, there's actually two solutions here we can check out. Again, we already went through this in the trees lecture section, but we're just going to go over the solution again here. So let's go ahead and jump to our solution, and we're going to start off with a few things to understand first. First, we have to understand the main difference between a binary tree and a binary search tree. So we know a binary tree is a tree data structure in which each node has at most 2 child nodes, thus binary meaning 2. And a binary search tree, BST, is based off a binary tree, but it has additional properties, basically 3 main properties. The left subtree of a node contains only nodes with keys less than the node's key. And then the right subtree of a node contains only nodes with keys greater than the node's key. And then both the left and right subtrees must also be binary search trees. So this is a really common interview question. It's actually really good because it really tests your understanding of the definition of a binary search tree. So how do we go about solving this problem? A lot of people make this mistake that what they're going to do is at every node check whether its value is larger than or equal to its left child and smaller than or equal to its right child. However, that approach is actually wrong because it doesn't check whether a node violates any condition with its grandparent or any of its ancestors. So you can't just check nodes to trees. What you have to do is keep track of the minimum and maximum values a node can take. And at each node, we're going to check whether its value is between the minimum and the maximum values it's allowed to take. So, we can actually do this by kind of typing out a class node and then working for a function to check that out. So let's go ahead and make a class node and just initialize it with self. And we'll just have it take on a value of none. And we'll have self.left equal to none, self.right equal to none, and then self.value equal to value, which by default is none. Okay, so then what we're going to do, now that we have our node class so we can build out trees and nodes, we're going to do this. We already know that we want to keep track of the minimum and maximum values a node can take. And at each node, we're going to check whether its value is between the min and max values it's allowed to take. Then the root can take any value between negative infinity and positive infinity. In case you're not familiar with Python too much, we can actually pass in infinity and negative infinity as floats. So I can say, let's just make it really obvious to put it in all caps, infinity, and have it be float, and you can pass a string infinity here, and that will be valid, and then we can do negative infinity like this. This is kind of just a trick with Python to pass these in as strings. See if that works. Alright, great. So what we're going to do is, we know the root can take any value between negative infinity and positive infinity. So we have those set up, and we also have our class node set up. At any node, its left child should be smaller than or equal to it than its own value. And then similarly, the right child should be larger than or equal to. So during recursion, what we're going to do is we send the current value as the new max to our left child and send the minimum as it is without changing. And then to the right child, we send the current value as the new min and send the max without changing. Let's go ahead and see how we do this. So here is our solution function. We'll call it isBST for is it a binary search tree. We're going to pass in a tree, pass in our minimum value of negative infinity, and then pass in our maximum value right now of infinity. Then we're going to say if tree is none, return true. And then we're going to say if not min val. So here we're going to actually be checking the tree val to make sure it fits in between these. So as long as our tree val is greater than or equal to, as long as our tree val is not greater than or equal to min val or less than or equal to max val, since we're using an if not here, we're going to return false. So we kind of have our base case checks, and then we're going to say is BST, here's our recursive call, tree.left, min val, and then tree.val. And we want to return is BST on tree right, tree.val, that current value, and then max val. Okay. So note the ordering there, and note how we're changing up the minimum and maximum values as we go along. Now that's one solution. If you're not worried about space in your big O, there's an equally good alternative solution. If a tree is a binary search tree, then traversing the tree in order should lead to the sorted order of the values in the tree. So this is actually kind of a nice, simple way to do it. You can actually perform an in-order traversal and then check whether the node values are sorted or not. So that one is usually makes sense to people. It's just a little more direct as far as how you're thinking about it. So let's go ahead and do that solution. And if you're having trouble remembering as far as in-order traversals or what a binary tree is, definitely make sure you check out the tree section of the course for a refresher. Okay, whoops. Let's go ahead and make this function, and it's going to take in a tree, and it's also going to take in an argument last node, and we'll call it negative infinity here. Then we're going to say if tree is none, return true. And I need to put a colon there, tab it over, and then if not is BST2, and we'll pass in the left of the tree and then the last node. We're going to return false. And then continuing on, we're going to say if that tree value is less than that first element of our last node list, we return false. And then we're going to build out that last node. That first element there is equal to the tree value. And then finally, we return is BST2 and pass in the right branch of that tree, tree right, and then the last node. Okay, so what are we doing here? We're just saying if a tree is a binary search tree, then doing an in-order traversal. So you can go ahead and check what an in-order traversal is back in the tree section in case you're not getting how we're implementing it here. So as I mentioned, an in-order tree traversal, if it's a binary search tree, that should actually lead to a sorted order of the values in the tree. So we can perform this in-order traversal and then check whether the node values are sorted or not. All right, so that's it for this question. Remember to check out the tree section and the tree lectures for a better breakdown of this. We went kind of quickly through it here because we're assuming that you've actually seen it in the tree section where we explain it in a little more detail than this. All right, well, with that being said, that's it. Hopefully you did well on it, and good luck in the rest of your mock interviews. Thanks, everyone.